Welcome to our unit on linear regression. Now, hopefully, if you did the first assignment, you realize that there are a lot of different variables that can impact the price of the house, both positively and negatively. Usually, you would think that the bigger houses automatically mean they're going to cost more money. Usually, that's the case, but not all the time. There's other factors that come into play. One of the biggest ones, most important ones, is the location. If you have a house that's in a more desirable location, the price is going to go up. Let's say you got a house right there on Lake Minnetonka. That house is going to cost a lot of money because a lot of people would really want to live on Lake Minnetonka. And it's not like they can just build an unlimited supply of lakes. If you have a house that has a lot of acreage, so you might have a pretty small house, but it comes with 20 acres of land, you have to pay for that land and the value of the house goes up. So lots of different things that go into the value of the house. And the one that we are going to be looking at as we do a linear regression is the size of the house. Typically, there's going to be a strong relationship between how big a house is and how much it costs. Smaller houses will usually cost less. Bigger houses will usually cost more. So what we're going to do today is something called a linear regression, and we're going to look at the mathematical relationship between the size of a house, the square footage, and the price of the house. And we're going to be looking at just houses in St. Paul. So we've accounted for a lot of the variables of location. Now, there's still pockets of St. Paul where the houses get really expensive, and some of them where they're not as expensive, but we've at least narrowed it down to one smaller area. So if you look at the assignment, there it is. If you look at the assignment, it gives you a list of 12 different houses that I've picked out in St. Paul. And it shows you both the square footage in the left column, and then it shows you the price in the right column. So this first house is 1,100 square feet. If I had to guess, that might be a like 2-bedroom, 2-bathroom house. If you go down here, you're going to see some bigger ones like this, 3,890. That's probably got like 5 bedrooms, 4 bathrooms, and of course, it's probably going to cost more money for that. So I just found a list of houses that are currently available in St. Paul. Actually, they're probably sold now. Like every house is selling right now. So these are all houses that were for sale at some point in St. Paul very recently. And what we're going to be doing is we are going to first type this table into Desmos. So you're going to go to Desmos. And on the very top left, you're going to see a plus sign up here. So that plus sign, you're going to click on that one. And then it's going to bring a drop down of different things that you can do. We're going to focus on the table. And it will bring up a blank table that you can start typing some things into. So we have to go back to our assignment, and we look at that first house, 1,100 square feet, $209,900. So let's type that into Desmos. 1,100 goes in the left column, that's the square footage. And in the right column, we're going $209,900. Now, even though in their assignment there's some commas on there, don't type the commas in when you're typing these numbers in. Desmos thinks the comma is something different, so just type them in without the commas. Then we're going to go to the next house, and we will once again have to type that in. So let's go to our assignment and look at the second house down. We have a house that's a little bit bigger, 1,914 square feet. That might have 3 or 4 bedrooms, 2 or 3 bathrooms. And that one is for sale for $339,000. So let's go back into Desmos and type that in. We have 1914 for the square footage, and we have $339,000. Now, I'm sure this would be an extremely exciting video watching me type these numbers in, but I'm going to save you a little time. Go ahead and pause the video, type the rest of them in on your own. And then when you are all done, come on back, and then we will proceed. So pause the video, type in all the numbers, and I'll see you in a second. Welcome back. Hopefully that was pretty painless. You might want to double check and make sure all of your numbers match what mine show you. If you type even one number wrong, your entire equation will look differently. Depending on which number you type in correctly, it might make a tiny difference or it might make a huge difference. So take a little time, double check all of the values that you inputted just to make sure they're correct. So the next thing that we're going to do is, you'll notice we're still looking at a graph here that just goes from -10 to 10. It's a pretty basic graph, but we need to see points that are much, much, much bigger than this, and data points that are, in the hundreds of thousands. So what we're going to do is we are going to click on the top right once again. So that little wrench, we're used to doing that. And where it says x-axis, we're going to change these numbers. So I want you to look down the left column, and I want you to look for the biggest house possible. And the biggest house we see was 3,890 square feet. I need to see x values that go bigger than that. So that's close to 4,000. I want to make sure my graph goes up to about 5,000. So we're going to go from -1,000 up to 5,000. Don't worry about why I picked negative. It's just so I can see. You could go from 0 if you want. It's fine. But the reason I chose 5,000 is because it's a little bit bigger than 3,890. So I'm going to be able to see all the values that are on that table. Now let's do let's put a label on there. The label for those was the square footage. That's going to be the size of the house, a measure called square footage. Then we're going to go to the y-axis, and if you look down that right column, I want you to look at the most expensive house, which also happened to be the biggest one. The most expensive house was 710,000. So I need to see numbers that exceed 710,000. Let's just pick 1,000,000. So we're going to go from -100,000 up to 1,000,000. That's a 1 with 6 zeros. And we're going to add a label for that. The label for this is going to be the price. So the y-coordinate represented the price. Once you've done that, click out of it, and you should see a bunch of dots that have showed up. So all of these dots represent a different house. So you could click on one of them. That's the biggest house. That's the one that was 3,890 for the square footage, and it cost $710,000. And you can see the smaller houses down here. A house that was only 644 square feet still costs $125,000. So you can tap on those dots to see which is which. So now what we're going to do is we're going to have Desmos draw a line. And it's going to draw a line that goes right through the middle of all of those dots. So you can kind of visualize. You're going to have a line that's going up and to the right. So it starts kind of low and then it shoots up towards the right. That line has what's called a positive correlation. Think of it kind of like the slope. So as the square footage of the house goes up, the price also goes up. It's a positive correlation. This line will have a positive slope. So now what we're going to do is I'm going to show you how to get the equation of that line. This is the important part. So on Desmos, we are going to type in a command. So the command that we're going to be using is very, very similar to just the equation of a line, y equals mx plus b, right? We're going to type in y1. So type in y followed by a 1. If you just type in y1, it automatically puts the 1 as a subscript. And that's just referencing that table that we just typed in. That right side was called y1. So if you scroll up here, you'll notice it was called y1. So just leave that as y1. And then by typing in y1, it references that list. Now we have to do, it's similar to an equal sign, but not quite. So if you hit the ABC button and on the bottom, there's something called a tilde. It's the squiggly line. It means kind of approximately. So y1 is approximately equal to mx1. Once again, it's referencing that x1 list, which is the left column on our table. So mx1 plus b. And you'll notice by doing that, it has now drawn a line that goes through the middle of all the dots. So that line that it just drew is the perfect middle line going through the middle of all those dots. So I won't go too much into it, but there's as many dots above it as there are below it. So we've found the line that goes through the middle of all those dots. One number that I want to point out, we won't focus on too much, but it's something called the R-squared value. So if you look where it says statistics on the left side, the closer that number is to 1, the better this line is going to be at predicting things. This is a 0.9. That's a pretty good R-squared value. So that basically just shows you the square footage is a pretty good predictor of the price of a house. So closer to 1 means better predictor. If you get a number like 0.15, that's pretty small R-squared value. Your dots would be scattered all over the place without a discernible pattern. But there are two numbers that we are going to look at especially, and that's the parameters, where it tells you the M and it tells you the B. If you remember, M stands for slope and B stands for the y-intercept. So what we're going to do is we're going to go back to our notes. First thing, you're going to want to post a screenshot just to prove that you did this. So go to Desmos. You can type your name in down here. Oops. So type your name and then it can prove that you did this on your own. Take a screenshot of that. What we're looking for in the screenshot is this display where it has y1 squiggly line mx1 plus b. We want to be able to see that m and that b value. So make sure you have that on your screenshot along with the dots in the line on the right side. I don't need to see all of these. I'll know that you have that based off of the dots. So screenshot this, import it into your assignment. And now we are going to go to the next part of this, and we'll deal with this in a separate video, but basically what I want to focus on right now is the equation of the line. If you look at Desmos, our slope was 187.086. I'm going to round that to just 187. So our equation of our line is going to be y equals 187x. So whatever your m was, that's going to be your slope. And then we look at the y-intercept. The y-intercept was 43,777.3. I'm going to get rid of that point. So 43,777. So plus 43,777. And that was your b value. That was your y-intercept. So by doing the linear regression, we have found the equation of the line that goes through the middle of all those dots. The equation of that black line that was drawn on there is what we just wrote down. So that's often called the line of best fit. That's what doing a linear regression does, is it finds the equation of that line for you. So you're all lucky that you have Desmos that's able to do this for you. If you really want to learn it by hand, I'm more than happy to teach you, but I think most of you are going to be pretty happy that you don't have to do this by hand. So thanks for watching this video. In the next one, we're just going to show you how to use that equation to interpret it and make predictions. And then that will be the basics of linear regression.